With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, there is a figure which is showing a long conductor which carries a current I. Now a rod PQ is of length L, which is in the plane of the rod. The rod is rotated about point P with a constant angular velocity omega as shown in the figure. We need to find the EMF which is induced in the rod in the position shown and indicate which would be at the higher potential. Now in this situation, so basically this is a current carrying conductor, so it would be having a current I. So for example, if we just take an element on this rod, let's say the thickness is dx, okay, so it would be moving with, or it would be having a velocity. What would be the velocity if the distance from here to here is x? So it would be having a velocity which would be given as omega into x. So velocity would be omega into x. So we can say that the small EMF which is induced into this length dx, this would be given as dE. This would be equals to b into v into dx. Okay, so it is bvl, or we can say that velocity value is omega into x. So we can say that it would be b omega into x into dx. Now if we can put the value of the b magnetic field at this point due to the wire, then we can easily integrate it to get the value of dE. Now what is the value of magnetic field due to a current carrying wire? It is given as mu naught I divided by 2 pi r, where r is the distance from the conductor at which we need to find the magnetic field. That means this would be the distance from here to here. This is the distance r which we are calling. Now how can we write this distance? So for example, if we just draw a line, so this angle is theta, so this would again be theta. So we can say that from here to here the distance is a, and what is the distance from here to here? It would be equals to x cos of theta. This would be x cos of theta, and this distance is what? This is equals to a. Now if we just make this substitution, the value of r has to be a plus x cos theta into this expression, and then we can give the value of b into this expression. Then we get the value of d, the EMF induced. This would be equals to mu naught I divided by 2 pi. Okay, it would be a plus x cos of theta, then it would be omega x, then it would be dx. Okay, now if we just integrate it, we can get the value of the total EMF which would be developed. Okay, this would be the case. Now what would be the limit of x? We can see that it would be varying from 0 to L. X, it would be from 0 to L. Okay, now theta would be changing, but we are integrating with respect to x. So what are the constant of constant of which we can take it to be outside? We can take mu naught I, then omega divided by 2 pi. Then it would be just integration of 0 to L, then x divided by a plus x cos theta multiplied by dx. Okay, we can just rewrite this integration term as, we just write, first of all we just write the constant term, and we can just write this constant term as 1 minus 1 divided by a plus x cos theta. Okay, then what we do, we just divide it by cos theta, so dx divided by cos theta. So there would be also a here. Okay, there would be a here. Now if we take the LCM, so LCM would be what? It would be a plus x cos theta. Now if we multiply this with a plus x cos theta, and if we subtract a, so a would get cancelled. It would be just in the numerator, it would be x cos theta. Now if we divide it by cos theta, it would be just only x, which is given in the question. Okay, or we can say that in our expression, not in the question but in our expression. Now it would be an easy integration. Then we can say that E would be equals to mu naught I omega divided by 2 pi cos of theta. So if we just integrate one, it would be this integration of 1 with respect to dx. So it would be equals to x. With respect to x, it would be x. We can put the limit from 0 to L, then minus a, and the integration, it would be treated as 1 divided by x because this is a linear term. So we can say that it would be in terms of log a plus x cos theta. Okay, and then we need to, because there is a coefficient of x which is cos theta, we need to divide it by the coefficient of x which is cos theta. We could put the limit from 0 to L. Now our EMF would then be equals to mu naught I omega divided by 2 pi cos of theta. If you put the limit of this here, upper limit L minus 0, lower limit, so it would be L minus a by cos theta, and if you put the limit here, it would be L ln a plus L cos theta divided by, if you put the limit of x as to be 0, it would be divided by a. So this would be the EMF which would be induced, okay, in the rod. Now we also need to indicate what is the which is at a higher potential. Now if we check for this part, we just draw this rod itself. Let's say this is our rod, and for example at this portion, okay, at this portion it is having a velocity in this direction. What is the direction of the magnetic field? Magnetic field is into the plane of the paper. Now if we use our right hand palm rule, okay, if we put our thumb into this direction and fingers into this direction, so the palm would indicate where the positive charge would be moving. Now in this situation we can say that if we place our thumb in this direction and this fingers into this direction, then palm would face this direction. That means there would be concentration of positive charge here. So positive charge would be moving here, or we can say that this would be at a higher potential. This would be at higher potential and this end would be at lower potential, because it is not the positive charge which would actually move, but we can just verify that. We can just say that the positive charge would move here, or we can say that this negative charge would be moving in the opposite direction. So wherever the negative charge move, it would be the lower potential. So this end would be at a higher and this would be at a lower potential. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.